Okay, any questions? What concept? All right, so let's have a quick look at a couple of these things with the lab. So with this rectangle thing, we get the code for that visible rectangle. Oh. So now when I make a new visible rectangle, oh, well that was stupid. What rectangle did I just make? Now I clicked on this one here. Well, let's find out. Oh, I have no. Oh, from rectangle. Okay, so I can call translate. And I can call to string. So the default one makes one with with everything 0, which is why it wasn't very visible. So let's not do that. And here it is. So it shows up like that. Now if I were to go and call translated on it, let me make it so we can see it all, and call translated on it by say 4050, then you can physically see it translating. And I had to put in quite a bit of code to make this happen. That I said don't really look at it because it'll take us probably to the end of the semester to really understand that code. So now if I wanted to move it back, then I translate by the opposite, and just by the negative, and it's back where I was. Now let me try the grow method, and I don't actually know what grow does, so we'll just try it out. And okay, it got bigger. Again, it's probably helpful to look at toString to see what actually happened. Now it goes to minus 95. What the? Okay. So originally it was 10, 5, 10, 20, 30, and now I grew it by. Does anyone remember what I grew it by? I think by 100 in each direction. So what? So how do I get from this thing here? So I did 100, 100 to this monstrosity here. And so for that, one way of finding that out is to let me call the grow method again. And here you see the Java comment that explains how grow works. So it's what's H and V? So I guess H is the first 100, and V is the second 100. So it subtracts those from X and Y. So it apparently goes in this direction by minus H, and then by minus H again. And I guess then in this direction it goes by plus H. And that's the bigger rectangle. So let's verify that 5 minus 100 is minus 95. That's what I have. And over here, this was 5 plus 20. That's 25 plus 100 is 125. Oh, I have my toString. Oh, I see. I don't see that because it tells me what the width of the whole thing is. And so from minus 95 to 125, that is in fact 220. So in other words, what it does is it grows it by 100 both to the left and to the right. So how do I shrink it back to its original size? Yeah, so if I just take the negative value of what I had before, then that should get back. So let me grow by minus 100, minus 100. And here it's right back to where it was supposed to be. Now, the only way to really figure this out is to actually read the Java.doc comment, which describes in gory detail what this method does. Because otherwise, you don't really know what does grow mean. Does it grow by a percentage? Does it make it 100 times as big? It turned out not to do that. If it had made it 100 times as big, then you would have had to shrink by doing grow by 0.001, right? So the only way to do that, to figure that out, is to actually read the documentation. And so here in BlueJ, you can find out the documentation when you try to call the method. Oops, down here. When you try to call the method, then as long as there was Java.doc documentation in the write-up, then it'll be reproduced here. All right, so so that's that. And so again, what I'm trying to get at here is that you gain expertise in taking an object of a class that someone else wrote, and that you can figure out how to call its methods and get them to do some useful effect. So here we've seen two methods, the translate and the grow methods, on a class that someone else wrote. This was the rectangle class from the standard library. And all I supplied here was to make it a little bit easier to visualize by putting up that little frame there to the right. All right, now on to the toaster. So we were supposed to do something in the beach chair. Put this in my scene, I think. Here. Okay, we'll put it down here. Yeah, we already have this. No, it said twice, whatever. Let's run it. That doesn't look like a beach chair to me. Yeah, why did I do that? Oh, that's because I have more than one project in here, and I have to make this one the default project. Somewhere on here is a thing that says make it the default. Huh? But this menu here is too big to fit. Then let's do it this way. Oh, set main project. Here we go. Oh, you're not being nice. Here, set main project. Oh. Okay, now we go. Okay, now it says hello world. It says it again, and it moves. Now we need to make a toaster. So a toaster is imported from this somewhat longish class name. Let's put that over here. So it's toaster Fred equals new toaster. And then now we want to do something on Fred. So when I just type the dot, notice that there's this long list of stuff popping up. NetBeans tries to help me out by giving me like everything that Fred could do. Now these objects can do a lot of stuff, which is why they're kind of amusing to play with, and why people like this whole Alice environment. So now as I type an M, then I get move, and I get 4 different move methods. And I just want the first one because that's what I asked you to do. So let's pick that one. I think if I hit enter, that's good. And now it already gives me the whole move direction left thing. So it seems to have gotten smarter than what I tried in last time around. And that's the one that I want. And now I don't want it I don't want this right now thing, which is actually the wrong guess by NetBeans. I just want it to move about 5. So here it does. Okay, how do I move it back? So So how do I move it back? I didn't ask that, but I'm asking you now.
To the right.
Yeah, so I guess if I moved it to the right, I don't know what happened if I move it to the left by -5. I could just try that. And interestingly enough, that did not work. So let's try to move it to the right. That doesn't move either. Oh, be darned. I have no idea. I hate it when that happens. So at this point, I would actually have to try to understand what move does. So let's see if we get.
Move it to the left again.
So I'm going to tickle out the java.doc comment. See if there is one. Now it says java.doc not found. So at this point, I'm kind of stuck. I honestly don't know what it's supposed to be doing because they're not telling me what it's doing. And that's a weakness of this Alice system that's still under beta, and they're not giving me all of the information that I need to know. I'll have to get back to you on that one.
Isn't Fred the toaster?
Yeah.
Not the chair?
Oh! You're absolutely right. Why did the chair? Oh, because I'm. Yes. You're absolutely right. Thank you. All right. So let's move Fred. Why didn't we see Fred move?
Yeah.
Because we're looking at the chair. Yeah. Where's Fred? Okay, no, he's not hiding behind the chair. What happens is we have to add Fred to the world. There's some magic thing. See here? That's that add component call. So we actually have to add Fred. Okay, now I'm going to give up on the chair here. We don't care about the chair. So here's good old Fred. Right? And that's why I say, well, that's a puny toaster. So how do we grow Fred? Was it resize? Is it a grow? Or did it? Resize. Okay, by what, 100? You said 20? Okay. Yeah, it's a large toaster. All right. So there we go. And so the whole point of this is that that Fred can do a million things, and some of them are useful. Like I can tell you that remove release listener is probably not going to be very useful, but resize sounds pretty good. I have no idea what resize and depth might do. So we're just using these toasters and things to play around and to get some nice visuals, so we don't have to know what all of the things are. And we'll be using them over and over for little examples. And it just turns out later when we study loops, it is a lot more fun to see the toaster go around a circle or trace out a spiral than it is to just print a bunch of numbers that change in value. So that was the whole motivation for doing this. But the key observation here is Fred is an object. An object can do certain things. What can it do? Well, whatever its methods are, in this case it's a long list of methods, each of them does something. You invoke the method by saying Fred dot, name of the method, then the name of the parameters. So I just wanted to hammer that into everyone. Now the other thing is there was a very good question by someone about the homework assignment. So what that person did is he had some string that state equals Massachusetts. And then he said state equals state dot, what was replace? And then he said what this had to do with those little bubble diagrams that I was drawing just at the end of the last lecture. And that was a very astute observation, really, because if we look at the bubble diagram, let's see what happens. So we're starting out with a string that contains Massachusetts. It's called state. And now we call it the replace method. What does replace do? It does not change all the A standards. What does it do? It makes a new string that has all the A's turned into @ signs. So this thing here makes a new string So let me draw the new string. It's over here. It's fresh and green. And it says SS at. Yeah, that's my new string. Now what happens to this string? This string is returned by the method, presented on a silver platter to yours truly. What happens next to that string? So far what we've looked at is everything that goes on to the right-hand side of this equal. Right, that was the method call. On the right-hand side, you have the method call. And then there's this equal. What does the equal do? Yes, and specifically what it does is it saves the address, where? In this slot here. So this thing here, the variable, can hold the location of an object. It used to hold the location of the string Massachusetts. And after the assignment, it now holds the location of the string. What happened to the original?
Still there.
It's still there somewhere, but no one remembers it. It's so sad. No one remembers it. What would happen to it eventually? It'll get garbage collected. So that's how it goes. Okay? So the important part is that this equal here does this reassignment. So it takes this new address and puts it into this variable. So, and then of course you can do it again and change the S's to $signs. And as long as you do that trick by reassigning it back to the variable, then this one will have been forgotten and the one with the $signs and the @ signs will be captured, and so on. But this is really, it's a very good way to visualize what goes on. And so I would encourage you to draw these diagrams with your own hands. When you watch me doing it, it's one thing, but if you draw them yourself, you have to ask yourself, what goes on. It's a very good exercise to understand how equals works. So the key observation is that when you call replace, somewhere a new object is born. And you don't know exactly how that happens because it goes on inside replace, but you know that object was created somewhere, it has the right information in it, and it is then handed to you. At this point, and really what truthfully is handed to you is not actually the object. What is handed to you is the location of the object. So really what honestly replace returns is it returns, say, at this location you shall find the answer. And then you can take that location and do something with it. All right. So we've now gotten to the end of chapter 2. We're going to be looking at chapter 3 next week. And so all of chapter 2 was really concerned with go for the kill here. Yes. Is he thinks it's an eraser. Yes, thank you. Objects, methods, method calls. Parameters. And I guess to some small degree classes. So the idea is someone made a class, you make an object of that class, you apply methods, you find out what methods are given to you, you call one of them, you feed parameters, you get the answer, you might store it in a variable because you might need to have it later. So it's all pretty straightforward stuff if you think about it. What's hard about it is that you deal with these classes that someone else has written. And each class is a world in its own right. Someone came up with rules for how that thing works. And you've seen me struggle with that too. I didn't exactly know what you can do with a toaster or with a car. It's just like someone gives you this large amount of functionality. And the reason we do that is that it's a great division of labor. Someone who understands rectangles very well, or someone who understands toasters really well, can implement those classes, and we get to use them without having to implement them from scratch. Particularly a toaster. I would not know for my life how to paint a toaster. That sounds like a hard undertaking. And someone has figured this thing out, and so I can just use that knowledge. Next, in the next week and a half or so, we're going to be trying to build our own classes, where we're going to supply our own methods, we're going to make them work, and the result is going to be much more modest. You're not going to be able to do a toaster on day one. You're going to be doing very, very simple classes so that you can see what goes on under the hood. But it'll show you very nicely what goes on under the hood, and it'll make this part, I think, a little bit easier to understand. What I want to achieve in the next lab is more of your using existing classes, and these classes are a little bit, they're also kind of interesting in what they're doing. So let's pull this up. So this is lab 2.5. So and these are parts of the code for the book. So if for whatever reason you have not done that, go ahead and download the book code. Do it now so that the network doesn't get overwhelmed when you start the lab. And so all of the files in the book are in the zip file, and it's awfully useful to have that handy. Then you want to start a project, and let me actually do this real quick. Yeah, I already made it. Okay. So now I've unzipped everything, and now when I run BlueJ, I'm in a somewhat different situation than where I've been before. Namely, I have already pre-created directories, and then there's a nicer way of dealing with that in BlueJ than what you've seen before. Where's my BlueJ here? What you do is you tell BlueJ that you want to open a non-BlueJ directory. Now you need to navigate to that. Oh no. No, I did something stupid. And it's fussy the way you have to do that. You have to go to the directory. So I put it in Big Java, chapter 2. The first one is day. And now I already stepped too far. No, I'm good. Now I'm good. And it gives me this. It gives me the classes that it has now found. And so now when I open it, yes. So now I got the classes that I want. So here I've written a class that computes calendar days, and this is a long and tedious computation here. You can see actually here how long this code is. This class knows about things that February has 28 days, except in leap years when it has 29 days, and it knows how to compute leap years and all of that. And you don't have to do any of this. What you're supposed to do is use this class. So this is a whole exercise in can you use a class that someone else has provided. So let's compile it. Let's make an object of it. There, you right-click on it, and you can see some methods. You know, what do these methods do? We could try to call one. It has the JavaDoc documentation on here. So it's another one of those things, can you use an existing class? The other one that I provided, you use in the same way, manipulates images. It lets you load an image. It doesn't matter. It lets you load the image, and then it shows you it gives you a few methods where you can manipulate the image. And kind of like the rectangle, like the visible rectangle, it's instantaneous. When you exercise the methods, then you see the changes right away. So that should be somewhat entertaining to use. So again, the whole point of this is to use existing classes and to manipulate them. And the other thing is I want you to do it in BlueJ without writing a line of code. So I want you again to practice how you can use BlueJ to investigate what objects do and how you can manipulate them in this interactive fashion, so that you gain more of an intuition as to what an object is and what it might be able to do for you and how you can find out what it should do. All right, so let's do that. We have about 45 minutes for it. That should be ample to do it. If you're done, submit your thing to Desire to Learn, but stick around for a few minutes so that I can give a wrap-up at the end.